guys, my name is Gloria. Welcome to my YouTube channel, the Math and Chem Hub. So in today's video, I will be unveiling the basic knowledge in electrolysis when it comes to chemistry. So this is the part one of this particular topic. The part one video for this particular topic, I'll be making other videos in electrolysis. But for today, we'll be learning the basic meaning of electrolysis and the terminologies in electrolysis, plus Faraday's first law of electrolysis. So that is what we are going to be learning today in this video. So welcome back. Like I said earlier, this is part one video for electrolysis. I'll be making another video under this topic where I'll be teaching the remaining parts of this topic. But in this first video, you're going to learn the meaning of electrolysis, the definition or the meaning of the terminologies under electrolysis, and the Faraday's first law of electrolysis. So stay with me. Let's go into this. Now, before I go into defining electrolysis, I would like to explain the meaning of the term electrolysis. Now, electrolysis is derived from two words. Electrolysis is derived from two words, electro, and lysis. Electro and lysis. Electro here means electricity, while lysis means splitting. Now, this simply means that electrolysis is all about splitting of chemical compounds, splitting of chemical compounds to form its constituent elements, right? Now, let's go into the definition of electrolysis. Electrolysis can simply be defined as a chemical process in which an electric current is passed through a substance, typically an electrolyte. Now, this substance that this electric current is passed through is known as an electrolyte. Now, and this electrolyte is always in a liquid form or in aqueous form. It is always in liquid form, right? Now, during electrolysis, what happens is that the ions in the electrolyte are driven to move towards the electrodes. Now we have the electrodes. I'm going to be explaining this. Now, these ions are driven to move towards the electrode by the electric current, basically direct current. This movement of ions result to the decomposition of the water electrolyte into its constituent element. So, this is what electrolysis is all about. So, for example, here I have electrolysis of water, whereby water is decomposed into its constituent elements, which are hydrogen gas and oxygen gas. Now let's look at the terminologies in electrolysis. Like when I was stating the definition of electrolysis, I mentioned various few terminologies there, but I'm going to be explaining. So I mentioned some terminologies or some terms under this electrolysis. First term that I mentioned when I was defining electrolysis was electrolyte. Electrolyte. Another term that I mentioned when I was defining was electrodes. I also mentioned cations and anion. Also, in electrolysis, we have the electrolytic cell. So we are going to be defining these terms one after the other to know their meaning. Now, let's start with anions. What are anions? Anions are the negatively charged ions. The negatively charged ions, right? So these negatively charged ions are attracted to the what? Anode. Because anodes are positively charged electrodes. I'll get to that. Now, in electricity, let me use the electrolytic cell to define these terms or to explain the meaning of this term. Now, we have the electrolytic cell here, and we have the cathode, we have the anode, we have the electron flow, we have the electrode, we have the um, positive electrode, which is the anode, we have the negative electrode, which is the cathode, and we have the electrolyte, which is the compound that is being decomposed. Now, looking at this electrolytic cell here, the anode, sorry, the electrode are electrodes are two. We have the anode here and we have the cathode. The cathode is the positively charged electrode. Sorry, the cathode is the negatively charged electrode, while the anode is the positively charged electrode. And I have the electrolyte here. Here I have the cell, I have the electron flow. Now, what happens is that when the current starts flowing into this particular cell, what happens is that when this compound decomposes into its individual element, let's assume that the compound we have here is sodium chloride as the electrolyte. When this compound called sodium chloride here as the electrolyte decomposes, the individual ions we move to their opposite electrode, the oppositively charged electrode, right? Now, what do I mean? Like we have, if I have sodium chloride as the electrolyte here, and it it was decomposed into sodium ion and chlorine ion, and I have sodium ion and chlorine ion here. Now, the sodium ion being positively charged will move to the cathode, which is the negative electrode, right? While the chlorine ion, being negatively charged, will move to the anode, which is the positive electrode, and that is why they are called cation and anions. The positively charged ions are called cations because they get attracted to the cathode, while the negatively charged ions are called anions because they are attracted to the what? Anode, right? So that is what happened. And the current, the electricity or the current flows in through the anode and goes out through the what? Cathode. The current flows in through the anode and goes out from the cathode. So anions are negatively charged ion which are attracted to the what? Anode, while the cations are the positively charged ion which are attracted to the what? Cathode. That is all about what happens in electrolytic cell. That is what happens in the electrolytic cell. So these are the terminologies that we have under electrolysis. We have the electrodes, which I said there are two types. We have the cathode and the anode. The electrodes are the conductors in form of wires. It can be copper wire or plates, right? Form of wires, rod or plate, through which an electric current leaves or enters the electrolyte. So these are the major terminologies under electrolysis. I've already explained the meaning of anions and cations. Also, I've explained that anodes are the positively charged electrodes and they attract the what? They attract the negatively charged ions, while cathodes are the positively charged the negatively charged electrode which attracts the what? Positive charge ion. And we have the electrolytic cell which I already described here. Now, these are the few um explanation or the explanation of terminologies under electrolysis. So for this, under this video, I'll be dropping a question here which is like an evaluation question. So you go ahead and answer this question and drop it in the comment section here. Now, so before I go ahead with describing electrolysis of some compounds here, I would like you to understand that there are a few factors or some factors that affect electrolysis. First of all, the nature of the electrolyte. The nature of the electrolyte. Now, because this electrolyte is going to be split into two, right? Into its individual. Sorry, it's going to be split into its individual elements. and the ions are going to migrate to the opposite or electrodes, they need to be mobile, they need to move. So because they need to move, because these ions need to be mobile, this electrolyte has to be liquid. It has to be in liquid form, right? For these ions to be able to be mobile, because solid compounds cannot move. They are one place, they cannot move. So for it to move, for it to get attracted to the electrode, the electrolyte has to be mobile. There are other factors like the nature of the electrode and so on. So these are the factors that affect electrolysis. Now let's look into the electrolysis of sodium chloride, right? Now sodium chloride, as I described earlier, is split into sodium ion and chlorine ion, right? Now what happens is that this sodium ion migrates to the cathode to accept electron and become discharged to produce what neutral what sodium atom. That is sodium ion here, solid, plus an electron loss to give what sodium atom. While the chlorine ion migrates to the anode to give up electron and become discharged to produce chlorine atom, right? The chlorine ion will migrate to the anode, which is the positively charged electrode, right, to give up electron and become what? Discharged to produce chlorine atom. And as we all know, chlorine is a diatomic element, right? So here we have two chlorine atoms to give what? Chlorine atom, right? To give chlorine gas. Now let's go into Faraday's first law of electrolysis, which is where our video is going to end today. Faraday's first law of electrolysis. Mind you, today's video is all about the theory aspect of electrolysis. In our next video, which will be the part 2 of this topic, I will be doing the calculation aspect of electrolysis. Now let's look into Faraday's first law of electrolysis. Faraday's first law of electrolysis states that the mass of an element discharged during an electrolysis of an electrolyte is directly proportional to the quantity of electricity passing through it. The mass or the amount of an element that is being discharged during an electrolysis is directly proportional to the quantity of electricity passing through it. That is Faraday's first law. Now we have the mathematical representation of this first law, which we have M is directly proportional to Q. M is directly proportional to Q, where M is the mass of the element that is discharged, and Q is the quantity of the electricity that is passing through it. Now, when we remove this sign of proportionality here, we're going to have M is directly proportional. Okay, M is directly proportional to, we'll introduce a constant here, EQ. But before I go ahead to explain that, let's not jump. Now look at this. We have Q. This Q here is quantity, and with our physics knowledge, we know that Q represents is also equal to current multiplied by time. Quantity of electricity is equal to IT, right? Current multiplied by time, right? So this means that M is directly proportional to IT, or M is directly proportional to EQ, or of to Q, sorry. Now when we remove the sign of proportionality, we're going to introduce the constant here, which is E. And E here, in some textbook you'll be seeing Z. They are all the same. E or Z here represent the electrochemical equivalence, right? The electrochemical equivalence, which is the what? A constant of proportionality in this particular um equation. So M is equal to EIT, or M is equal to EQ, where E is the constant of proportionality known as electrochemical equivalence, right? So that is that about Faraday's first law of electrolysis. This means that as the mass of the substance discharged is increasing, the quantity of electricity is also increasing.